Exercise 183, page 462, question number 1. Two parts to this question, and actually, having gone through these solutions, I've put another extension question at the end for you to have a go at, exactly like these ones here. So in the first case, we've got to integrate 5x squared with respect to x, and then put the limits 1 and 4 in, integrate between 1 and 4. The function is plotted below, y equals 5x squared on autograph, and what we're finding is the area underneath the curve between the points 1 and 4. So if I were to sketch that out, I'll be finding this area here underneath the curve. Okay, using the convention, the integral between the limits 1 and 4 of 5x squared dx will equal, bringing the 5 outside, I like to try and do that, the constant can come outside, x squared dx. You don't have to take the constant outside, you get exactly the same answer if you left it inside. Now integrating x squared, add 1 to the power divided by the new power. This equals x cubed over 3 between the limits 1 and 4. Again, I can bring the divide by 3 outside and divide the 5 by 3, leaving just x cubed inside the bracket. But again, you don't need to. You get exactly the same answer if you left the 3 inside. It just makes the arithmetic a little bit easier. Now I'm going to put the limits in. So using the convention of curly brackets to represent the fact I'm putting the limits in. So the top limit first, 4, x equals 4 cubed. Take away the bottom limit, which is 1. So 1 cubed. So putting the limits in, it's the top limit, making x the top limit, and then subtract the bottom limit. And working this out, we get this equals 5/3. 4 cubed is 64, minus 1 cubed is 1. And you'll get the answer in the text. Part B, again, we've got to integrate this between now the limits 1 and minus 1. And the function this time is minus 3/4 t squared. Again, it's a quadratic function. The t squared tells me that. And if I plot the function on autograph, you can see the quadratic curve. And I'm finding the area between minus 1 and plus 1. So this is minus 1, and this is plus 1. So I'm finding this area here. So putting those limits in, I'll end up with this area, which is twice the area between 0 and 1. So I could actually find the area between 0 and 1, and then double it. And in some cases, playing around with the negative signs is difficult, so it's worth doing it that way. But we'll just put these limits in as they are. So again, what am I going to do? I'm going to integrate between the limits minus 1 and plus 1, minus 3/4 t squared with respect to t. I can, to make the life easier for myself, take the minus 3/4 outside the integral. Now I'm going to do the integral, add 1 to the power, divide by the new power. So this becomes t cubed over 3 between the limits minus 1 and 1. Again, I can bring the 3 outside, the divide by 3, so this becomes minus 3/4 times 3, leaving t cubed inside the square brackets between minus 1 and 1. You can see here that the 3's cancel, so we end up with minus 1/4 square brackets t cubed between the limits minus 1 and 1. I've taken the constants outside all the way through here, but if you'd left them inside, you would still get exactly the same answer. So this equals minus 1/4. Now using the convention for putting the limits in, curly bracket, put the top limit in first, 1 cubed minus, then put the bottom limit in, minus 1 cubed. Just got to be a bit careful with signs here. So it's minus a quarter, 1 cubed is 1, minus 1 cubed is minus 1. Minus 1 times minus 1 is 1, times minus 1 is minus 1. So this is minus 1, which is plus 1. So this becomes minus 1 quarter times 2. And you get the answer in the text. Right, an extension question. Integrate a cubic relationship this time, minus a half x cubed with respect to x between the limits 3 and minus 2. So I've sketched out the curve. This is a cubic relationship this time, but the process is exactly the same. So I'm going between minus 2 and 3, which is here. And so you're finding this area here. Have a go, put in the values, and see if you get the answer. Pause this and try it. The answer follows. You should get that the area is minus 65/8 or minus 8.125.